is the surface, load bear, and impact and subgrade. We can know that the subgrade work zone is from the surface, the pavement surface to depth, depth. Now this is for medium humidity. From this table from this picture we can know that the capillary rise depth is from the water level on this level to this. But the work zone is below the capillary rise height.
Yes.
So we can determine the work zone is belong to medium humidity state. But when the work zone dA is only to this level, which state is the subgrade? Subgrade is in which state? When the A is from here to here.
So, Lars, say that again.
JA is not this area, is from the top of the surface to this level.
Okay.
To this level. When this, we can know that the subgrade is in which state? Dry, medium, humidity, or humidity.
H is close to 0, that level, so...
From here to here is up to this level. It's in dry state. So, from this we can know that the work zone is influenced by the capillary rise. If the capillary rise is not influenced the work zone, so the subgrade is in dry state. But when it is is influenced by the capillary rise, so it's in medium wet or medium humidity state. But in this picture, it is in medium humidity state. So the work zone is from the top of the surface to calculate. And this is the ground surface, and the water table or water level. When the capillary rise to this level, when the work zone dA is less, from this we can know that it is in dry state. But in this, it is below the capillary rise level. It is in medium humidity state. So we can know that according to the HE is the capillary rise state.
Capillary dry state.
Capillary rise state. And then H.
It's HE.
We can know H1 or another. It's okay. H1 is the subgrade heat. Subgrade heat. And H is what?
Wall.
Is the heat is from water table to roadbed, the top of the roadbed. Okay. Now, from this we can know that 陆基工作区 is a work zone, a subgrade work zone, and this is water level, and this is matrix suction model. It is from this we can know that this heat it is influenced by climatic factors. 受气候因素的影响 is climatic factors, and this is influenced by water table or groundwater. Groundwater. This is belong to 中湿类型陆基的湿度状况 It is medium wet or medium humidity state. Saturation of subgrade and equilibrium humidity. For wet subgrade, saturation is determined according to the heat of water level. Now, from this table, we can know that for different groups of soil, it's GM, GC, S, silt, sand, and silt, 粘刺沙, silt and sand and clay, and other different groups of soil. We can know that we should know how to calculate point from the groundwater and the accumulated pounding the depth. We should know which, for example, when the distance to the groundwater is 1 meters, and for sand soil, it is the saturation of soil of sand is 50 to 70%. But for another, when the depth to the groundwater is larger than 1 meter, we should not concede or calculate the saturation of sand, because the temporary rise in sand is low than 1 meter. But for low limit, high limit clay, we can know that even the depth to the water table is 4 meters. We can know that the saturation of soil is 66 to 83%. Because in no limit clay, the temperature rise is higher than in sand soil. So for different kind of soils, the Cambridge rise is different. This is for wet subgrade. And for dry subgrade, saturation is determined according to TMI. This is the different natural zone for TMI. This is the table. From the table, we can know that for different natural zones and different areas, and TMI is different. So this is the for dry subgrade. For example, when we take two natural zone and 黑龙江, the TMI is minus 0.1 to minus 8.1 is the TMI range. So for dry subgradation, we can use this table to determine the saturation of soil. Now, when we got the TMI range, we can use this table to and according to different soil group to determine the saturation of soil in the different subgrade. When we know the TMI and the different group, soil group, for example, for sand, and TMI is 10, and the saturation is 30 to 65%. So this is for dry subgrade. We should know first the TMI, and according to TMI and soil, different soil groups, to determine the saturation of soil. So we can obtain the saturation for different group of soil. For medium wet subgrade or medium humidity subgrade, saturation is determined according to weighted value of those of dry and wet subgrade. But for wet subgrade, we can only consider the water level influencing. But for dry subgrade, we can only consider the climatic factors. Just we'll know the TMI and the different group of soil to determine the saturation. But for medium wet subgrade, we should know according to the dry state and wet state to determine the saturation according to weighted value of those of dry and wet subgrade. Firstly, the equilibrium humidity of the upper and lower parts of subgrade water zone are determined respectively. Just one is for dry and then one is for wet. We can calculate it respectively. Equilibrium humidity of subgrade determined by the thickness weighted mean. 在厚度加权 thickness weighted mean. This is the when we know how to determine the saturation of soil for different types of state in the work zone. Another, we talk about the classification and engineering properties of subgrade soil. Soil formation is about formation process and forming conditions. When we see the soil, where it is come from? Rock. Why? Why is so the rock is changed to soil?
Because of the weather.
The weather.
Weathering.
Weathering.
Yeah.
Weathering is just like about the water,
Wind and stuff. Yeah.
wind,
That's the weather.
and another.
Yeah.
Just in the river, and the flow is transfer it to one area to another. So, the format process and conditions will determine the soil, determine different soil, just like red clay, expensive soil, or sand. This is weathering different conditions will result in different soil. So the physical and mechanical properties of soil are different. We should know according to the specific soil to determine how it is acted. So, plant formed under different conditions after weathering in nature and history. It's not 1 year, 2 years. It's about 1,000 or longer to form the soil. So, we can know that soil and earth and weathering, transportation and deposition to form soil. So when we determine or talk about the rock, it is weakly weathering or strongly weathering rock. So it is according to the weathering conditions. Now, from this table, we can know that grain composition of soil. So, how do we determine the soil in different groups? Well, according to the grain composition. From this, one is the British specification. It's about, according to the grain size, just like this, 0.001 is to 1,000 millimeters. Can you know that? 0.001 into 1,000 millimeters. We can divide it to clay. It's less than 0.002 millimeters. We can, this means clay. And it's larger is silt, sand, gravel, is
Cobalt.
cobalt or
Cobalt.
cobalt and boulders.
Boulders.
The largest is boulders. In Chinese is 巨力主，巨大。
巨大。
我们 this is the Chinese specification. But for the USCS and H2 and STM, the specification for the soil is different. So when we determined, we should, according to different specification, when we used in China, we should in Chinese specification, but in British, we should use this British specification to determine the soil groups. So we should know that which, according to the green size, to determine the soil group. This is a comparison of 5 systems for describing soils based on particle size, and coefficient curvature. From this, the CU is D60. D60 is the diameter of the soil particles for which 60% of the particles are final. And the 10 is the diameter of the soil particles for which 10% of the particles are final. Both of these diameters are obtained from grading curve. According to the sieve, different sieve size to determine. And the coefficient of curvature, D30 is the diameter of the soil particles for which 30% of the particles are final, and the average particle diameter is the 50. This is the 2 parameters we should to know. This is the soil. This is the table about the soil types, descriptions, and average grain sizes according to ASTM D2487. This is the soil types: gravel, sand, silt, and clay. And description, we can know that gravel is rounded and or angular, bulky hard rock, costly divided. And the clay, its particles are smooth and mostly clay minimums exist. Significant strength when dry. Water reduces the strength. This is the clay and is less than 0.002 millimeter. And the silt is 0.075 millimeter to 0.002 millimeters. But for the gravel is fine or coarse, according to 19 millimeters to 4.75 millimeters. Okay. Okay, this is the unified soil classification system flow chart for coarse grain soils. We should look. Firstly, we should determine are 50% of particles is large than 0.075 millimeters. If yes, soil is coarse grained. Or no, soil is fine grained. And we will continue to proceed to flow chart of figure later we are talking about. So when we should, according to the particle size, to determine it is green, coarse green or fine green. But when it is green gradually, we should determine its grammar fraction or sand fraction. And yes or no, soil is grammar, first letter, and G, and soil is sand, first letter is S. And if it's clay, silt fraction is, we should conceive the 12% and 5%, and between 5 and 12%. So we should decide the particle size. If it is larger than 12%, is clay fraction larger than silt fraction? Yes, we have plastic clay, clayer fine, second letter C, and non-plastic fines, second letter M. And if it is less than 5%, we'll continue to this. If the first letter is G, we'll continue to Cu is not less than 4, or Cs is between 1 to 3. Determine is the second letter is where, W is where, and the other second is poor. If first letter is S, we also determine Cu and Cc. So we'll continue from one stage to another is according to the particle size. When we determine that it is to belong to clay or silt, if it belongs to clay, if it belongs to the silt, we can determine the Cu and the Cs to determine it is well grade or poor grade. So this is the for coarse grain soils. But it's between 5 to 12%, and it's clay fraction or silt fraction. And it's yes, and the first letter is G. And also you can determine the Cu and the Cs. So this is the same procedure. This is the unified soil classification system flow chart for fine graining the soil. It's also according to 50% particles is this or 0.075 millimeters. Yes, it's fine grain, and no, we proceed coarse grain. It's just this. Now, we should also determine the liquid limit. It's over dried or not dried. And yes, soil is organic. The first letter is O. And if no, we should determine it is belong to clay fraction or silt fraction. And if yes, its clay fraction is larger than silt fraction, well, can soil is clay first is C or is M. So when the liquid limit is larger than 50%, we should plasticity is higher, second letter is H, is high plasticity or is low. So this is the for unified soil classification system flow chart for fine grained soils. This is more details. Flow chart classification coarse grained soil more than 50 retained on number 200. See. So when we to determine the soil belong to which groups, so we should carry out or perform the C test first. When we determine the seal test, when we according to the seal test, we are according to this flow chart to determine it is belong to coarse grain or fine grain or clay or high clay or organ high clay or limit high clay. So we are according to this flow to classifying coarse grain soil in organic fine grain soils, 50% or more fines. We are according to this. And we should know the limit, the liquid limit. And this is a flow chart for classifying organic fine grain soils. And engineering use chart. For different type of lengths of soil groups, they have different mechanical and these properties. So we should, according to the soil groups, it's just like important properties: permeability when compacted, and the shearing strength when compacted and saturated. Compressibility when compacted and saturated, workability as construction materials. We should, according to the soil groups, and determine how to use them to fill the subgrade. For some soil, it is not able to fill subgrade, but some of them are good or excellent for fill subgrade. So we should determine to the soil belong to which groups. Okay, this is a classification standard in China. Well, can classify it according to the characteristics of particle composition, plasticity index, and the existence of organic matter in soil. And four categories, namely huge green soil, coarse green soil, fine grained soil, and special soil. In total, there are 12 types. And special soil is noise, semi-moist soils, and frozen noise, rapidly and expensive soil is a special soil. And another is huge green or coarse green and fine green. So today class is over, and next class